unit conversions, and I'm going to do unit conversions here by example. So I know that as students kind of go on, I have actually 4 different types of examples. They're kind of from different fields all over the place, and they're done like that on purpose because I think unit conversions is a neat concept that students should know. If you may remember, so unit conversions actually is a proportion problem. So it's a direct proportion problem where you're just scaling one with respect to another, and it just turns out that we do utilize different units. So what do we mean by units in general in terms of conversions? Well, you can see, for example, example number 1, which is probably the most applicable because most students will understand it, because there are many currencies in the world that we use in terms of trying to make payments. So there's, for example, here it's asking us to convert euros to US dollars. Now, but we can convert any currency, right? I mean, now we even have, Bitcoin and Ethereum and all of these different digital currencies. So, you can convert one to another, and it's just a scaling proportion problem. I actually use unit conversions just simply by unit cancellations, right? So I kind of call it a unit cancellation method, where all I'm doing is, someone gives me a particular measurement, it might be money, and then I want to convert it back to another measurement in terms of units. So I'm just changing the unit, I'm just changing the scale that I'm going to be using it by. So I'm going to show you these 4 examples. Now, one thing for unit conversions that students should know is definitely you should be familiar with, for example, prefixes, right? So metric prefixes. Things maybe like, you've heard milli or micro or kilo or centi. So that you should actually know. So I am assuming that you kind of know that. If you want, I did actually a full out video on metric prefixes. I'll put up a link up above there for that. And from those, metric prefixes, I kind of want students to remember, these. So where you have a base unit and then you can transfer those, so going into, for example, to the right, you have deci, centi, milli, just going up to micro there, but you can go smaller. And then it goes deca, hecto, kilo, and then mega. Again, you can go much bigger. So those are the prefixes I'm referring to. So that you can watch in that link I provided. So now let's dive into these actual examples and see how we can use, these proportions and unit cancellations to be able to scale from one unit to another. So the way that I approach these is someone always gives you what it is that they want you to convert. So I just simply take that number. So for instance, I'm going to take 328.50, and this is euros. So I do keep the actual unit itself. It's kind of hard for me to write the euros there. But now what I will do is I will just cancel. All I want really is I want to change this to US dollars. And, you can look up, obviously these change every day, so it's not like currencies are fixed. It just depends how the countries are doing. So, the currencies keep fluctuating. So these things, so you can look it up. Probably today when you're watching this, it might be different than it is, okay, for instance, to these ratios that I've given you here. So for here it says $1, at least kind of today, is approximately 1.2398 Canadian dollars. And then $1 Canadian is 0.7032 euros. Now, if you have a conversion that's direct from euros to US, then you can use that. But most of the time when you're doing these things, teachers might give you the actual conversions and then you have to use those because you can't really look them up, right, in terms of the net. But maybe you do, all right? So here I'm giving you an example where I give you 2 conversions between US dollars, Canadian dollars, and then Canadian dollars and euros. Now, how do I use them? So I'm going to use them in the following way. So conversions, unit conversions, are proportions. So it's going to be multiplications. And now what I like to do is, well, I want to always get rid of what I do not want. So here, I don't want to have my money to be in euros. So I know that if I wanted to cancel this off, right, and I was multiplying, I know that I would have to have euros here in the denominator. so that it cancels the euros here in the numerator. So these two things have to cancel. And what I do next is I actually go and see the ratios that they give me and see, okay, where did they give me euros? Now, where I see euros is right here, because I see that 1 Canadian dollar, so it's relating Canadian dollars to euros. I don't want my answer to be in Canadian dollar, but that's the only place that I do see euros. So what I'll do is, since the euros are here, so that goes in the denominator, I do enter the actual number in, so that is the scaling factor that I have. So that's what I have there. And then this Canadian dollar is going to go on top. So this is going to be 1 Canadian dollar. So this conversion would have converted euros to Canadian dollars. So notice that's the only unit that you would have left. And I can find out what that is by multiplying 328.50 times 1 and then dividing by 0.7032. Now, that's not what I want. What I want is I want to change it to US dollars. So I will continue this unit cancellation. So I'm going to continue the multiplications. Now again, I'm going to scale it again. Because now what I have is, now I have Canadian dollars right here. And I want to get rid of these Canadian dollars. So I'm going to put them here in the denominator. Right? So I definitely know that I want to get rid of these Canadian dollars. Now, because I already used Canadian dollars from this ratio, you're not going to use it again. You're going to have to find a different ratio. And that ratio, so I see right here, because it relates back for me, Canadian dollars, so that's 1.2398 to 1 US dollar. And now notice what happens is that the Canadian dollars right here, these are going to be canceling each other off. And all you will have left is exactly what you wanted, which is US dollars. So this is a transition from euros to US. And we call this basically, I don't know what the true name of it is. I know that it's a proportion because you're just scaling, but I just call it unit cancellations, where I'm just canceling things. You start with 1, you don't want it, you put it at the bottom, dot cancels, you write down the ratio. And then you continue using the ratios until you finally get what you want, in this case, US dollars. So what would this equal? So how we take this out? So we basically write this out. So 328.50. And then all I'm going to do is I'm going to just take all of these and multiply. So what I like to do is I take all the numerators, I multiply them together. I'll hit equals. Now in this case, I'm just multiplying by 1. And then after that, so that answer, I'm going to be dividing. And I'm going to divide individually by each one. So for example, here, so divided by 0. This is going to be 7,032, okay, equals. Now, I do hit equals because I've done the division, all right? Now, this would have been the conversion to Canadian dollars because that's after the first one. So now that answer that I have, I still have to divide. So don't round, just let the calculator keep it. And now I'm going to be dividing by 1.2398. Okay, and then that equals. So this is going to be, 376. Now this I will round because it is money. So this is going to be 79. And this is US dollars. And that completes the actual conversion for me. Now, how you enter these things into the calculator, it doesn't really matter as long as you're doing the correct order of operations, all right? But in terms of the cancellations, that's how this unit conversion would have worked. So that's one example. Let's take a look at a completely different example. Okay, so here, for instance, this is my second example that I have. It's 246 grams, so it's some kind of a mass, and we want to convert it to LBS, so that's pounds. Now they do tell us right here that 1 kilogram is equal to 2.2 pounds. So I have a scaling factor between kilograms and pounds, right? It's approximately around that much. But my original that I actually have in terms of my given right here, so that mass is in grams, right? Now, I don't want to have grams I want to have pounds at the end. But my ratio that they give me is between kilograms and pounds. So actually the first thing that I have to do is I have to change this back to kilograms in some way. And this is where the prefixes come in. Now, some people may remember 1 kilogram equals 1,000 grams, or, gram is the base. So I'm going to just use the prefixes because we're going from gram, which is the base, to kilo. Okay, so that is kind of shifting the decimal over. So this would have been moving over, so this decimal by 3 spots to be able to get to kilograms. And that's just from prefixes. So I know that this is going to be equal to 0.246 kilograms. Or you can just kind of take it, and remember that 1 kilogram is equal to 1,000 grams. And that will do the trick for you as well, okay, if you don't want to kind of recall all the prefixes. So that's what I will do first. And now from here, I am going to use here, so this ratio. So I don't want to have kilograms. So I'm going to put kilograms at the bottom, so that cancels. I'm going to write the 1, so that comes from there. And I'm going to write the 2.2 pounds on top to get my cancellations out. So that means this. Now, there's nothing else. I now have exactly what I wanted, which is pounds right here. So I can just go ahead and multiply. Now, in this case, it's much simpler. This is just this times 2.2, which is going to be 0. And sorry about that. Let me just change the 0.5412 in pounds. Now, they didn't really ask us to round. I'm sure probably your teachers will ask you to round, and you can round correctly, to whatever it is that you want. And that would have been the conversion here. So again, it's just a scaling. So first I just change the prefix, and then I use the ratio between kilograms and pounds, so the scaling factor, and then I could have just multiplied through. All right, so that's example number 2. So here is another example again, something much different. So here we have an example where we have 0.675 liters per hour. So I guess it's some kind of a rate of volume per hour. Maybe it's flowing, I don't know, maybe it's an IV, or who knows, maybe it's water, something, okay, that is flowing. And they're asking you to convert it to milliliters per minute. Now notice in this example, they don't give us any assumptions. So we're kind of stuck. We have to be able to figure this out on our own in terms of converting. And when you do have units, and then you have 1 unit on top and then 1 unit at the bottom, what I suggest is always convert first. Okay, so first, worry about the units that are on top. So we want to change liters to milliliters. Once we do that, then we will worry about the denominator. Don't try to, do things right at once, okay, and change it all one into the other. So here, the way that I would set this up is I would do this. Okay, well, it's 0.675, okay, so it's liters per hour. Now, I don't want to have liters here. I want to have milliliters. Now, I'm not going to worry about the hour, okay, in the denominator, but I am going to worry about the liter. Now, liter is a base for volume. Now, milliliters, okay, so you may recall, so that's basically you're going to have to shift that decimal 3 spaces over, right? So from the base, it goes to deci, centi, and then milli. So I'm going to have to shift this thing over. Now, this is going to be to the right, so it's going to be 675 milliliters for every hour. So those are equivalent. Now, once I changed the numerator, now I can worry about the denominator. Now, the denominator is in hours. I don't want to have hours, I want to have minutes. So what I'm going to do now is I'm going to multiply this. Now, what am I going to multiply? I'm going to have to relate hours and minutes together. That's something that you should know. We know that there are 60 minutes in 1 hour. So where does the hour go? Well, the hour is going to go on top because it has to cancel this off. In order to cancel, one has to be at the bottom, one has to be on top. And that 1 hour is equal to 60 minutes, and the 60 minutes you'll put at the bottom. And now from here, well, all you do now is you just can take, so it's going to be 675 It's going to be times 1, which is still 675, and then divided by 60. And that's going to be 11.25 milliliters per every minute. So whatever this was a flow for, that would have been the answer. Again, if you have to round and they ask you, you can. Here they don't ask us to round, so we'll just keep it as it is. All right? And that is the conversion. So that's another conversion that you can do and you can think about. Here is a last example that I have for you. So this one is interesting. So this definitely is for sure from health sciences in some way, because it says convert 125 microliters to cc's. Now, for those who don't know, so cc is cubic centimeters. And it does actually lay this out right here. So notice you have 1 centimeters cubed is actually 1 cc. That's kind of what is used, and mostly it's used in healthcare. I don't really see it much used kind of in other fields, but I guess you can also use it kind of in chemistry or something like that in laboratories if you're using volumes. So let's try this one. So what do I have? I have 125 microliters, okay? And now I want to be able to convert this to basically cubic centimeters. Well, the first thing is I do see, so, liters is my base here. Micro is my prefix. I do see a liter right here, but I don't see microliters. Now, I can convert, so I can actually go from microliters to liters if I wanted to, because it's a prefix, right? So now, micro, so it kind of goes deci, right? Centi, milli, micro. But micro jumps 3 spots. You may remember that. Okay, so here from the prefixes. So notice, here I have a liter, and here is micro. So I'm actually going to be going in this direction. 1, 2, 3, 4. It seems like it's 4 spots. But don't forget that micro, okay, actually counts. To go from micro to milli, that's actually 3 spots. And then the rest is just 1 spot. So I'm going to be jumping here 6 spots over to get from micro just to liters. So this is going to be going 1, 2, 3, and then again 1, 2, and 3. So it's going to be a very small number here. 1, 2, 3, and 125. And now it is liters. Now, why did I do that? I did it because here they're giving me an assumption. They're relating liters to meters cubed, right? That's what they are relating. So they're relating it back to meters cubed. I want it in centimeters cubed. But if I have meters cubed, then to go from meters to centimeters, that's just a prefix change. So I'm going to just show you that in a moment. So this is equal to that. Now I'm going to say, okay, well, I don't want to have liters. So I'm going to use this. So I'm going to put the liters here at the bottom. Okay, and then the meters cubed is going to go on top. But notice it is meters cubed. So this liters cancels, right? So this is what I have right here. And so this is going to make it even smaller. So now when you multiply these two things together, this is going to be a disaster here, but that's okay. So it's going to be 0 point. Now when you're multiplying this, it's going to be another 3 spots right here. And 1, 2, 3, 125. If you don't trust me, you can kind of look it up. You can also change it back to scientific notation if you want to, so you don't have to carry all of these decimal places. I mean, that's up to you. But now changing it back to centimeters cubed. Well, right now, what do I have it in? I have it in meters cubed. That's what I have it. And I want to have it in centimeters cubed. So I have to go from here to centimeters cubed. That's what I have to do. So now, it is volume that I am changing. So here, let me delete all of this stuff. Now I have, this is meters, right? But it's cubed. And you may remember from prefixes. So centimeters is just 2 over, right? So this is centimeters cubed here. So I want to be able to go in this direction. 1, 2 from meters to centimeters, but it is cubed. Because it's cubed, that means each of these spots that I am moving over is basically 3 spots. And then this is going to be another 3 spots because of the cube. If you were just moving from meters to centimeters, then that would have been 2 spots over, right? If it was from meters squared for area to centimeters squared, then each jump is 2. But if you're going to be moving from meters cubed to centimeters cubed, that means each jump is actually 3 spots. And that's the tricky part here. So this is what it's going to be. We're going to the right, so it's going to be 1, 2, 3, and then 1, 2, 3. So this actually brings us to 0.125 centimeters cubed. But, wait a minute, centimeter cubed is 1 cc. So these are equivalent. So this is 0.125 cc's. And that would have been your final answer. All right? So that's how you would be able to do this conversion. So conversions in general are not super easy, especially if you start throwing in prefixes. But I hope that these examples, illustrate to you how to approach them and what to think about. And also make you realize that, you do kind of have to be comfortable with some metric prefixes because they do pop up. So now go back and try the examples on your own so that you can try to convert all of these directly, and then you can just check what the answers were. Okay, thanks for watching. We'll see you in a future video. Bye, everybody.